Astronomers have found a cosmic collision that is just waiting to happen. J0749 plus 2255 is a merging galaxy that contains not one, but two supermassive black holes that are actively feeding on matter. Unexpectedly, these two black holes are on a collision trajectory and are only separated by a little distance of 10,000 light-years. Both black holes are extraordinarily active quasars that have been observed early in the history of the universe. It's a finding that could aid researchers in solving the difficult and ongoing mystery of how supermassive black holes evolved to such enormous masses. At the early stage of the universe, we don't observe many double quasars. And for that reason, this discovery is so fascinating. One of the brightest things in the universe are quasars. They have an active galactic nucleus, which is the galaxy's core and home to a supermassive black hole that is actively gobbling up enormous quantities of matter. There is currently no evidence that black holes emit any light of their own. Due to intense friction and gravity, the enormous amount of material swirling around the black hole is heated, causing it to not only glow but also burn across the wide, dark chasms of time and space. Quasar galaxies are common in the early universe, and some of the closest galaxies feature 2 or 3 quasars in their centers. This happens when galaxies that each contain a supermassive black hole collide and merge. As the two black holes collide, they combine to produce a single, enormous supermassive black hole. But in the early universe, it is a little more difficult to detect these mergers. In comparison to objects that are far closer to us, the light from J0749 plus 2255 has traveled for more than 10 billion years to reach us. As a result, the galaxy appears small and dark to us. The space between supermassive black holes that are connected by gravity is typically too small for our detectors to see at that distance. This galaxy of quasars is unique. Since they are both quasars, the black holes glow brightly enough to be distinguished from one another. Additionally, they are still too far apart to be considered a gravitationally bound pair, leaving enough space between them for individual resolution. Astronomers examined the light from this object using data from a large number of telescopes located both on the ground and in space. They found that in about 220 million years, the two black holes will most likely merge into a gravitationally bound tight binary. This binary will eventually collide and combine into an even more powerful black hole as a result of its orbital decay. Researchers also discovered that the two black holes are quite small, with respective masses of 1.58 billion and 1.26 billion solar masses. These results may provide some insight into the frequency of twin supermassive black holes in the early universe, which would aid astronomers in understanding the evolution of more recent black holes, some of which can reach sizes of billions of solar masses.